Remember the little mathematical virtual machine we made using the unreachable statement? Well, there were two problems with the way we were using opcodes. Having to remember opcodes by number is no good. We had to use unreachable because Zig had no way to knowing how many values of P could. There were. An enum is a ziglings construct that lets you give names to numeric values and store them in a set. They look a lot like error sets. Const fruit enum apple pear orange. Const my fruit.apple. Let's use an enum in place of numbers we were using in the previous version. Please complete the enum. Yeah, so ink, oops, how, and deck. Yeah, ink deck pow. No has needed. Why is that? Because these three options is the whole enum possibility, so we don't need other. Okay, good. Let's try. Yeah, pass. Okay. Let's go to the next one. 36. Yeah. Enums are really just a set of numbers. You can leave the numbering up to the compiler, or you can assign them explicitly. You can even simplify the numeric type used. So, const enum of unsigned 8 and foo is 16. Okay, so you can get the integer out with a built-in function int from enum. We'll learn about built-ins properly in a later exercise. Const my stuff. Okay. Note how that built-in function starts with hat, just like the hat import function we was using. Yeah. Zig lets us write integer in hexadecimal format. OXF is the value 15 in X. Web browser let us specify color using hexadecimal number, where each byte represents the brightness of the red, green, or blue component RGB, where two X digits are one byte with a value of 0 to 255. Please define and use a pure blue value color. Okay, I don't know. I think looking at the other FF. Okay. Remember, Zix multi-line strings. They are here. They are again. Also check out the school formatting. Type X is lowercase hexadecimal. Separator needed for format syntax. Padding character default is alignment, align right, width, use padding to force width. That is lowercase hexadecimal. Semicolon separator needed for format syntax, padding character, alignment, right, 6. Okay. Color dot blue. Okay. Okay. Being able to group values together, let's just turn these. Point 1x3, point 1y16, point 1x27, point 2x7, point 2y13, point 2z, point 2z or 34 into this. Yeah, okay. The point above is an example of a structure. Use of the struct type could have been defined as const point struct x epsilon z. Okay, let's store something fun with a struct. A role-playing character will use a handle to specify the character role. Wizard if bar warrior. Please add a new property to this structure called health and make it an U8. Okay. Health. Okay. Please initialize Golorp with 100 of health. Okay. Ouch, Golorp takes a punch. Yeah. Okay. Next one is the 38. Grouping values in structs is not merely convenient, it also allows us to treat the values as a single item when storing them, passing them to function, etc. This exercise demonstrates how we can store structs in an array and how doing so lets us print them using Okay, and now done, so let's us print them using a loop. Okay. Role character. Yeah. Pub function main, void character undefined, char 0 is this one. Okay. Okay, oops. Okay. Okay. If you try running the program without the examp as mentioned above, you can word a pair to be garbage value. So what the hell if I run this one, what I 037 38 no 20 120. Okay. One zero one zero one zero in binary to hold and define location to make them easier to spot when debugging. This is a strange, interesting but strange. Oh, pointers. Check this out. Var foo unsigned height equal 5. Var bar is a pointer to unsigned height but equal ampersand foo. What is a pointer is a reference to a value. In this example, bar is reference to a memory space that currently contains the value 5. A cheat sheet given the above declaration. Who height the type of unsigned height value. Foo the value 5. The type of a pointer to a unsigned height value. Ampersand foo a reference to foo. Bar a pointer to the value at foo. And bar dot star the value 5, the reference value at bar. Okay. We'll see why pointers are useful in a moment. For now, see if you can make this example work. Okay, var num1 unsigned height 5 const num pointer. Okay, num2 is undefined. Please make num2 equal 5 using num1 pointer. See the chart sheet above for an idea. So num2 is equal num1 pointer dot star. Okay. Yeah. Cool. It's important to note that variable pointers and constraint pointers are different types, given var foo unsigned height, const bar unsigned height. Then foo is type star, ok, mentre hbar is type of percent const you height. You can also make a const pointer to a mutable value, var, but you can make a var pointer to a mutable value. Okay, yeah, that makes sense, yes. This sounds like a logic puzzle, but it just means that once data is declared immutable, you can't coherence it to a mutable type. Think of mutable data as being volatile or even dangerous. Ziggle always lets you to make more safe and never less safe. Yeah, so fix this. Why? Exactly what is the problem here? Const state, yes, const. And this look correct. I have to write const yeah, okay, cool. The tricky part is that the pointer's mutability, various const, refers to the ability to change what the pointer points to, not the ability to change a value at that location. Const locked use 8 equal 5. Var unlocked u8 equal 10. Const pure, const wait locked. Var p2, okay, both p1 and p2 points to constant values which cannot change. However, p2 can be changed to point the memory as and p1 cannot. Const p3 is equal, okay, unlocked. Oh fuck. p3 and p4 can both be used to change the value they point to, but p3 cannot point at anything else. What's interesting is that p5 and p6 act like p1, p2, but point to the value at unlock. Okay, this is what we mean when we say that we can make a constant to any value. Okay. Okay. Interesting. This is interesting. Okay. Please define pointer p so that it can point to either woo or bar and change the value it points to. Var p is a pointer to unsigned height. Oops. Okay, pass. Now let's add pointers to do something we haven't been able to do before. Pass a value by reference to a function. We wish to pass a pointer to an integer variable rather than the integer value itself, because then we are allowed to change the value of the variable passed by reference where you want to change a pointed to value, otherwise pass the value. Okay, this function should take a reference to a unsigned height value and set it to 5. Okay. X dot star equal 5. Yeah. Yeah. Okay. As with integers, you can pass a pointer to a struct when you will wish to modify the struct. Pointers are also useful when you need to store a reference to a struct. Okay, pointers are also useful when you need to store a reference to a struct, a link to it. Const vertex, struct, x, okay. Var what you okay. Var pv vertex okay, a pointer to our struct. No, that you don't need to reference the pv in pointer. Oh, I don't like this. I don't like this. I really don't like this shit. This is only a thing that can make confusion. I don't like this. I really don't like this. We can write functions that take pointers to structs as arguments. This foo function modifies struct v. Function v and call them like so. Let's revisit our RPG example and make a print character function that takes a character by reference. Okay. Oh. Okay. Okay, I don't tell to anyone. You can provide a full value. Okay. Cool. So I have to pass glorp Okay. Glorp. Why there is a problem? Oh, I don't know. Note how these functions C parameter is appointed to a charset structure. Is something you haven't seen before. When switching an enum, you don't have to write the full enum name. Zig understands that .wizard means class.wizard when we switch to an A class enum value. Okay, 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 claro. If I switch on C.class, class C is obviously of type class, so yeah, okay. Checking an optional value on the capture hit will be explained later. This part is with okay. Okay, 33. This is very constant. Is this the error? Why? Good. Okay. But there is another problem. Yeah, okay. Yeah. I need to. Okay, this now it will work. No? Why? Okay. Yeah. Elephant walking along the trails are holding hands by holding tails. From holding hands by learn hand link. Okay. Okay. Then the elephant so that each tail points to the next elephant. Okay, so the elephant b dot tail equal elephant. Okay. Okay. Sometimes you know that a variable might hold a value. It might not. Zig has a neat way to expressing this. Is called no what? This idea called optionals. An optional type just has a question mark like okay. Now foo can store unsigned certified integer or null, a value storing the cosmic horror of a value not existing. Okay, before we can use the optional value as the non-null type, we need to guarantee that it isn't null. Okay. Deep throat. Please throw in the results. So the answer is either the integer value from the or the number 35. Okay, blast from the past. Optionals are a lot like error union types, which can either hold a value or an error. Likewise, the or else statement is like the catch statement used to unwrap a value or supply the full value. Yeah, okay. Error.heavy. Okay. Now that we have optional types, we can apply them to the last time we check in with our elephant. We have we had to link all three of them together in a cycle. So that the link to the first elephant, this is because we had a tail that didn't point to another elephant. We also introduced the point shortcut. Is the same as bar or else unreachable. Need something. Ooh. Ooh, fuck, I don't remember how to do this. I had to do to okay, but how I can define a full okay, so oops 46 no a big question undefined but why I don't understand why we need null if we have already undefined its value. Link elephant, we start the program, you should try and link an elephant that doesn't exist. And comment and see what happens. Ah. Okay. Hmm. Hmm. I don't understand. Okay. Okay. I'm not sure that I really understood what I do, but hey, this is not my problem. 47. Okay. Help. Evil alien creatures have hidden eggs all over the earth and they're starting to hatch. Before you jump into the battle, you need to know three things. One, you can attack function to extract. Okay. Another type definition. Extract function hello. Who says hello? Yeah, okay. A function that is a member of a struct is a namespace within the struct and is called by specifying the namespace and then use it syntax. The net feature of this function is that their first argument is an instance of the struct or a pointer to one. Then we can use the instance as the namespace instead of the type. The const bar, okay, struct ABC. Is a fucking object, is an object, but zig is an object oriented programming language. No, what the hell? Imperative. I'm not so sure, cioè, this is a fucking object with a self. Ok, vabbè. Ok. Notice that the name of the parameter doesn't matter. Some use self, others use a lowercase version of the name type, but feel free to use whatever is most appropriate. Okay, you're armed. Now, please up the alien stars until they're all gone or the hair will down. Look at this hideous alien struct. Know your enemy. Health. We hate this method. Hit ray. Damage. We love this method. Self alien dot health minus equal if self dot damage is greater than alien dot health, altrimenti self dot damage. Yeah. Alien in hatch. What do you mean edge? Chiudere, ok. Aliens alive is equal aliens.len healthray.damage 7 will be given an healthray weapon. We'll keep checking to see if we will kill all the aliens yet. Aliens, okay, aliens alive equals 0. Okay. Look through every aliens by reference. Oh. Okay. What the heck? Zap the alien. What is... Why this? Okay. Zap the alien with the health right here. Health ray. Hit ray. Dot zap. alien okay. If the alien cells is still above zero, is still alive, yeah. Okay, Earth is saved. 47, yeah. Well, let's see if we can help our elephants out a bit more with some elephant method. Get tails, says tails, visit, print. Okay. Elephant A, B, C. This link the elephant so that each tail points to the next. Okay, visit elephant, elephant A. This function visits all the elephants on, starting with the first elephant and following the tails to the next elephant. While true, print, visit. Okay. This get the next elephant or stop. Which method then do we have here? If E has tail, E dot get tail, else back. Zigzenum can also have methods. This comment originally asked if anyone could find instance of a method in the wild. Buccianti. Let's see what is okay. 49. Trunk's tail is anything from holding hands by Lenormand link. Link. Now that we have tails, we'll figure how you can implement trunks. Vabbè, is like this other. I can copy and I can paste it, but is not more tail, but trunk, and in the other way is not more tail but trunk. Okay, let's see if this work. Okay. Okay. We live on a places island of ignorance in the midst of black seas of infinity, and this was not mean that we should voyage far. Zig is a list for ways of expressing no value. Undefined, yeah. Therefore, undefined. Undefined should not be through of as a value, but as a way of delete a compile that you are not assigning a value yet. Any type may be set to undefined, but attempt to read or use that value is always a mistake. Null. The null primitive value is a value that means no value. This is typically used with optional types as with the question mark on side 8 show above. When foo equals null, that's not a value of type on side 8. It means there is no value of type on side 8 at all. Error. What the hell? What the fucking hell? Error are very similar to null. They are a value, but they usually indicate that the real value we are looking for does not exist. Instead, you have an error. The example error union type of my error means exclamation mark answer height means that foo either holds an answer height value or an error. This is no value of type answer height in foo when it's set to an error. The last void, therefore void. Void is a type, not a value. It is the most popular for the 0-bit types. This type which takes up absolute not space and have only a semantic value. When compiled to executable code, 0-bit types generate no code at all. The above example shows a variable foo of type void which is assigned the value of an happy expression. Okay, it's much more common to see void as the return type of a function that returns nothing. Zig as a whole of this way to expressing different type of no value because there is several pros briefly. Undefined, there is no value yet. This must be read yet. Now there is an explicit value of no value. Error, there is no value because something went wrong. There will never be a value stored. Please use the correct no value for each to make this program print out a course quote, then necromion, if it's there. So, the first line is undefined because is undefined. Oops. Okay. The second line is undefined. No. Cthulhu. This is not. We need the for the error union string. Oh, I think that work. I don't know. I'm not sure, but 50 passa. Ok. If you thought that the last exercise was a deep dive, hold on to your nut because we are about to descend into the computer's molten core. Shutting down here, the bits and bytes flow from RAM to the CPU like a hot, dense fluid. The force are incredible, but how does all of this relate to the data in our Zig programs? Let's head back up to the next editor and find out. That's better. Now we can look at some familiar Zig code. Import as the imported code to your own. In this case, code from the standard library is added to your program and compiled with it. All of these will be loaded into the RAM when it runs. Oh, and that thing we name const std data structure. Okay, of a character structure. It is stored in your program as data, and like the instruction code, it is loaded into the RAM when your program runs. The relative location of this data is in memory is a hard coded and neither the address nor the values change. Okay. Also, when a function executes, the input arguments are often loaded into the beefing area of the CPU set. Okay. Okay, so can I find stt dot debug debug dot print. Oh, oops. Debug dot print. Okay, now let's look at an assignment and point to value in Zig. We'll try three different ways of making a new name to access our glorp character and change one of its values. Glorp access 1 is incorrectly named. Okay. Note, if we try to do this with a constant character instead of a var, change the called field, will give a compiler error because const value are immutable. Yeah. Okay, yeah. No. Yeah. Okay. Yeah, I'm in it. Yeah. If we try to do this with a yeah, point does not work. Yeah. Moving along when arguments are pressed off cost with the function. Okay. So okay. Okay. So maybe here I have to pass opla okay a glorp and here I expect yeah, and there's more data segment allocated at compile time and the stack allocated at the runtime are the only place where program data can be stored in memory. They're just the most efficient. Sometimes we don't know how much memory our program will need until the program is running. Also, there is a limit of the size of stack memory in a program. You can use as much of heap memory as you like, with its physical limitation, of course, but it's much less efficient to manage because there is no built CPU support for adding the memory items as we have with the stack. Also, depending on the type of the location, your program may have no expensive work to manage the use of heap memory. We'll learn about the heap allocation later. Well, this has been a lot of information. You'll be pleased to know that the next exercise gets us back to learning the language feature. We can use the right way to do more. Okay. Okay. Exercise 22. Slices. We seen the passing array around the outward. What mean? Young word. Imbarazzante. Imbarazzante. Perhaps you remember a particularly horrendous function defined from quiz 3. This function can only take arrays that are exactly 4 items long. Yeah, that's the trouble with array. Their size is a part of the data types and must be hard-coded into the every usage of the type. This digit array is also, yeah, okay. Thankfully, Ziggle slices, which lets you dynamically point to a start item and provide a length. Here a slice of your digit array, digit 01, digit 39, digit 3, okay. Okay. As you can see, a slice 6 dot dot y starts with the index of the first item at the x and the last item at the y minus 1. You can leave the y off to get the rest of the items. The type of a slice on array of height, oh yeah, okay. A4K A5 Please put the first 4 cards in hand 1 and the rest in hand 2. So 0 dot dot 4 4 dot dot. Yes. Please lend this function a hand. A slice, okay. So here I can say assign 8. Yeah. Fun fact, under Heud, slices are stored as a pointer to the first item and a length. Yeah. Yeah. You are perhaps tempted to try slicing a string. There are arrays of unsigned characters after all, right? Slices on strings work great. They're just one hitch. Don't forget that these string literals are immutable values, so we need to change the type of slice from. Okay, see if you can fix this zero wing inspired phrase disclaimer. What mean this? Disclaimer. Great base for all your uses are belong us. Okay. Okay. And the exactly same thing here. And maybe also here, I'm not sure, so I want to try to run. Yeah. So I have to exactly do the same thing here. Yeah. Yeah. Take a good look at an array. Okay. You can also make pointers to multiple items without using a slice. A foo is a four-space array of unsigned 8. Foo slice is a slice of a foo, so it's no more an array, but it's a slice. Okay. Foo pointer is a slice, no, of a pointer. Why the star is inside of a bracket? This sounds strange. It, okay. Okay. Oh. 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 Okay. Okay. Take a good look at the array type to which we're coercing. The Zen 12 string, the real nature of string will be revealed when we learn some additional feature. Okay, memory is a resource. Okay. It will also have been valid to coherence to a slice. Okay. Now let's turn this into a many items pointer. I'm not sure if this will work, but I don't know. Or maybe no. So maybe it was correct before. No. I don't know why this. I maybe should for instance. Oh fuck. Pointer to an array of two unsigned int. Pointer to unknown number of unsigned. Why? Why the star is here and not here? This was so more clear in my opinion. But I'm not. Pointer unknown number of immutable. Pointer to an array of two. Pointer to an immutable slice. So then many pointer is a pointer to unknown number of immutable. Okay. So, uh, why I can do this? Hmm. Error in the syntax required for unknown len. Hmm. I should say no. What is the error here? Hmm. I don't understand. I really don't understand. I don't understand. I'm not sure that I can that I really understand the the goal of this exercise. I done it, but I'm not confident with this argument. I'm really not confident with this argument. Okay. Okay, in this example, a union lets you use store different types and size of data at the same memory address. How this is possible? The compiler sets aside enough memory for the largest thing you might want to store. So full takes uh, a union let you store different types and sizes of data at the same memory address. How it is possible? The compiler sets aside enough memory for the largest thing you might want to store. In this example, an instance of foo always take up inside 34 of space in memory, even if you couldn't store it at all. Okay. The syntax looks just like a struct, but a foo can only hold a small, or a medium, or a large value. Once a field becomes active, the other inactive fields cannot be accessed. To change active field assignment, a whole new instance. Var f foo small plus error, okay. F equal new, okay. Union can save space in memory because they let you reuse the space in memory. They also provide a sort of primitive polymorphism. Here, foobar can take a foo no matter what size of assigned integer it holds. Oh, but how does foobar know which field is active? Zig is a neat way to keep in track, but for now we'll just have to do manually. Let's see if you can get this program working. We just started write a simple ecosystem simulation. Insect will be represented by heater, bees, and hens. Bees store the number of flowers they visited that day, and hens just store whatever or not they still alive. Okay. Since we need to specify the type of insect, we'll use an enum. Remember, A or B. Ant or B. A, B. We'll just make some and one hand to test them out. Hand still alive, B. Flower visited, 15. Ok. Eccentric Dr. Zootropea says that we can only use one function to predict our Dr. Z is small and sometimes inscrutable, but we do not question here. What it is? Okay. Oh. Okay. It is really quite inconvenient having to manually keep track of this active field in our union, isn't it? Thankfully, Zig also has taken to union, which allows us to store an enum value within our union representing which field is active. Foo tag small, medium, large. Const Mm, what the fucking hell? So we can put an enum type of a union. What the fucking hell? Let's make our insect use a tagged union. Dr. Zotroprea approves. Insect states. Flower visit is still alive. Okay. I have a const and okay. And b switch insect dot. By the way, did unions remind you of optional values and errors? Optional values are basically null unions, and error use error union types. Okay. Why take the union is get even better. If you don't have a need for a separate enum, you can define an inference enum with your union all in one place. Just use the enum keyword in place of the tag type. Let's convert insect.tropea has already related the explicit insect stat enum for you. Thank you. Inferred enum are neat. What neat mean? Pulito, okay. Representing the tip of the iceberg in the relationship between enums and the unions. You can actually coherence a union to an enum, which gives you the active field from the union as an enum. What's even wilder is that you can coerce an enum to a union, but don't get too excited. They only works when the union type is one of these weird 0 bytes like void. Tagged unions, as with most ideas in computer science, have a long history going to the 1960s. However, there's only recently become mainstream, particularly in system-level programming language. You might have also seen them called variants, some types, or even enums. Okay. Okay, but I'm not sure that I agree with this. With this. With this. We absorbed a lot of information about the variants of type we can use in Zig. Roughly, in order we have the single item pointer, and the slice size no at runtime array. Many item pointer to many item. Okay. Set of unique value I and B. Set of unique error values E and F. Group of value Y, Z, single value either or. Okay. Value of any of these above types can be assigned as value or constant. So allow or disallow change. We can also make error union or optional types for error. Knowing all of this, maybe we can help out a local hermit. He made a little zig program to help him plan his trips through the woods. But it's a some mistake. A note about this exercise. You do not have to read and understand every bit of this program. This is a very big example. Feel free to skim through it and just focus on a few paths that are actually broken. What? What? Okay. Okay, Const trip error. A reachable hidden by a group. Let's start with the place on the map. Each is a name and a distance or different of travel. Note that we declare the place as mutable var because we need to assign the path later. And why is that? Because path contains pointers to places, assign them and assign them now will create the dependency loop. Okay. Const place is a struct with a name and with a path. A, B, C, D, E, F are all a place, a variable of type place. Okay. Okay. We'll be reserving memory in our program based on the number of places on the map. Not that we do not have to specify the type of this value because we don't actually use it. In our program once it's compiled. Don't worry if this doesn't make sense yet. Okay. Okay. Now let's create all of the path between sides. A path was a place. Okay. Goes from one place to another and as a distance from to distance. By the way, if the following goal seems like a lot of tedious manual labor, you write one of these killer features is letting us write code that runs at compile time to automate repetitive code. Much like macros in other language, but we haven't learned how to do that yet. Okay, so the A path is a slice of path then that actually contain a path from A to B with distance 2. Okay, the path of B, okay, from B to Archer, okay. Okay. Once we plot the best course through the woods, we'll make a trip out of this. A trip is a series of places connected by path. We use a trip item union to allow both places and path to be in the same array. Trip item. This is a little helper function to print the two different types for item correctly. Function print me self. Trip item switch self. Oops, the hermit forgot to capture the union values in a switch statement. Please capture each value as P. What the fucking hell? AF. Okay. A hermit notebook is where all the magic happens. In the notebook, the entry is the place discovered on the map, along with the math taken. Okay. If we find a better path to reach a place, shorter distance, we update the entry. Entries also serve as a to-do list, which is how we keep track of which path to explore next. Okay, place, coming from, via path to reach. The Hermit notebooks is abstract. Remember that array, repetition, repeater. Okay, it's not. It's ok. Ok. Quindi without we use it to initialize an array with null value. The next entry okay is where Hermit got stuck. We need to return an optional pointer to a notebook. Okay. What we have with entry is the opposite. Oh fuck. To get one from the other, we need to difference entry and get the node. And return the address. Oh, 1, 2, 3, 4. Maybe this parenthesis is too much. much, too much, too much, too much. The line 3, 2, 1. Okay. The function need to return an error if the requested destination okay. The group we absorbed a lot of information about the no okay. I just do it. Okay. Unicode pointer. Unicode point that can take up 21 bits. Okay. You can also place underscores in numbers to hide. Ah, okay. Octal, binary, hexadecimal. Octal, binary, hexadecimal. Right? E 73. G. The G is number 71. 71 in hexadecimal is 47. Okay. 47. Fuck. I want the lower case. E. 105. G. G lowercase 103. 103 in hexadecimal. 77. 67. Huh? Single item table pointers can correspond to a single item.